All right, for our day 3 probability assignment or our lesson, we're going to continue talking about probability, obviously, but here we're going to do some area model problems. Okay, so Jessica is conducting an experiment in which she flips a fair coin and then rolls a fair die. So use the area model below to determine the probability that the coin will show a heads and the die will show a 5. So actually, you can do these two different ways. I'll show you how to do it both ways. So first of all, I'm going to fill in the area model, how they'd like you to do it here. So we say H1, we'd say heads 2, heads 3, heads 4, heads 5, and heads 6. Okay, so these are all heads, and then we get our numbers from above. So these are going to be tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6. Okay, now we're trying to get a heads and a 5. Well, this is the only place that actually happens. So it happens one time out of 2. I have 2 events here and I have 6 events here, so 12. So it happens 1 out of 12 times. Now, another way I can do this, okay, what's the probability of getting a heads? Well, to get a heads, that's 1 out of 2. Okay, what's the probability that I get a 5? Well, that's 1 out of 6. So I need to do 1/2 times 1/6, which is also 1/12. So I can do it either mathematically or I can do it using this area model. Moving on, for an experiment, Mike plans to flip a coin and roll a fair 6-sided die at the same time. So again, the same thing here. I'm looking for a H1, H2, H3, H4, H5, and H6. This would be a tails 1, tails 2, tails 3, tails 4, tails 5, and then a tails 6. It says use the area model above to determine the probability that the coin will land on heads, and the number is greater than 4. Okay, so I want heads, so basically all of these are possible, and then I want it greater than 4. So this is greater than 4, and so is this one. So I have 2 out of, okay, again, I have 2 by 6, so that's 12. Okay, I can simplify that to be 1/6. So I have a 1 out of 6 chance of getting a heads and a number greater than 4. Again, I can do this mathematically. I can say, okay, what's the probability that I get heads? Well, that's 1 out of 2. And what's the probability of a number greater than 4? Well, again, 5 and 6 are greater than 4. So that's 2 out of 6, or 1/3. Multiply across, and I'm going to get 1/6. So either way you do it, you can do it mathematically or you can do it with the area model, but we should get 1/6 either way. All right, for an experiment, Portia plans to roll a fair 10-sided die and a fair 4-sided die, and then find the sum of the 2 dice. So there's a key word here, sum, that means to add. So right here, we're going to do 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4. You kind of see the pattern here, so I'm just going to go 5, 6, 7, 8, 9, 10, 11. And then we're going to do 2 plus 1 is 3, and 4, 5, 6, 7, 8, 9, 10, 11, and 12. 3 plus 1 is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then 4 plus 1 is 5, 4 plus 2 is 6, and we have 7, 8, 9, 10, 11, 12, 13, and 14. So again, we're using the area model above to determine the probability that the sum of the dice is 10. So I'm looking for all the 10s. So I have 1, 2, 3, 4 10s. 10s don't show up anywhere else. So that means I have 4 out of, okay, take a look here. I have 4 here and I have 10 here. So 4 times 10 is 40. And I can simplify that to be 1/10. Okay, this one would actually be pretty difficult to do just mathematically, because we actually do need to know the sum. So I would say that using the area model for this problem is pretty much the only way we can do it. So if you see one that says sum, you know that you're just going to have to fill this out and and figure out how many of this value we have and put it over your total number. How did we find the total number? I took these four numbers and I multiplied by 10. So 4 times 10 is 40. Okay, so for an experiment, Alicia plans to spin two different spinners with equal sized sections. The first spinner has sections labeled red, orange, yellow, green, and blue. The second spinner has sections labeled with the numbers 1 to 5. So use the area model above to determine the probability that the spinner will land on orange or green, and the second will land on an odd number. So I'm looking for orange and green, and then I'm looking for an odd number. So I'm going to kind of mark those so I remember what I'm doing. Again, as I fill this out, I'm going to say red 1, red 2, red 3, red 4, red 5. Now, you might not actually have to do this, because if you have them marked here, you might be able to figure out where those are going to be. So this is going to be orange 1, orange 2, orange 3, orange 4, orange 5. Okay, yellow 1, yellow 2, yellow 3, yellow 4, yellow 5. We do green 1, green 2, green 3, green 4, and green 5. And we're going to do blue 1, blue 2, blue 3, blue 4, and blue 5. Okay, so now let's figure out which ones are the orange or blue, or excuse me, orange or green, and odd numbers. So we have orange 1, 3, and 5, and we have green 1, 3, and 5. All the other ones really don't matter for us, except for it helps fill out all of our outcomes. So I have 6 that fit that category. Okay, now take a look here. We have 1, 2, 3, 4, 5, and I have 5 up here. So 5 times 5 is 25. So my probability of getting an orange or a green and a odd number is 6 out of 25. Okay, now again, we can do this mathematically. We can say, well, how many orange or greens do I have? That's 2 out of 5, times how many odd numbers? That's 3 out of 5, and I can multiply those together to get 6 out of 25. So again, find out your probabilities of each event, 2 out of 5 for the two colors, 3 out of 5 for the odd numbers, and then multiply them together. So that's another way you can do this. An experiment consists of rolling 2 fair die and adding the dots of the two sides facing up. So what is the probability that the sum of the dots is 12? Okay, well, since it says sum, we know we have to use an area model, but this one's already filled out for us. So 12 only shows up one time. So that's 1 out of what? Well, I have 6 here, and I have 6 here, so 6 times 6 is 36. So I have a 1 out of 36 chance of getting a sum of 12, or a sum of 12 when I roll 2 6-sided die. All right, and that was our last example for our day 3 probability lesson.